The next part of this is going to be kind of a trip, I think, because you wouldn't necessarily normally think of doing exactly the same command twice, but that's kind of precisely what we're going to do in this case, right? So we want a grid that is fully parametric that has cells that are going to also be fully parametric, right? So we are going to create a subdivided domain. But I'll show you first how to set it up on the side, right? So if we have the same surface here and we want to do another subdivide surface, I can go up to the Surface tab, go into Utility, do an isotrim, and then instead of having it be fully parametric, I can actually do divide domain, or what was it? Yeah, divide domain squared, rather than construct domain. So the difference is that constructing the domain will create an entirely new surface of which your parameters, your minimum and maximum domain, is going to be referenced to the actual built environment. For us, we're going to take the actual built environment and we're going to make it non-modifiable at the perimeter. So it'll just be a straight divide. Okay, so it's significant because again, this subdivide has a U and a V. Okay, the U and the V, like I described in the last video, they behave very, very similarly to X and Y, except they communicate well in three-dimensional space, right? Because they warp across a surface and they have irregular spacing, but they will always intersect perpendicularly, I think. What happens here? What's that?
That's all calculated.
Yeah, essentially. So what's happening here is that it's going to ask for the base domain, which would be basically, what am I subdividing? So that speaks in a geometry input, and then it'll ask you for the U and the V subdivisions. So that's very much like setting up your grid. Your grid is going to have a count, an X count and a Y count. And then it'll also have an X spacing and a Y spacing. But when you have a domain, the spacing is only predicated upon subdividing the minimum and maximum value. So if I have a surface that's 10 by 10, and that's my domain, then my minimum is 0 and my maximum is 10. And if I subdivide it 10 times, every spacing is going to be 1. Right? So, but when you do it in 3D space, it's not the same because all of the spaces that are happening in the center of your saddle are going to be far smaller and narrower. Well, actually, they'll be more square than they will be at the perimeter. They'll be narrower at the perimeter at the tall points, and then they'll be wider at the bottom points, right? Something like that. So the way that this works is it's kind of like a triangle here. We need to drop in a couple more sliders, and these sliders are going to be real number sliders, integer sliders. So it'll be 0 less than, say, 5, less than 10. I'm just going with that illustratively. And then you plug those into the U and the V. And then you also plug the surface into the I. And then that becomes, right, because the output of that, this little, it's not really clear in the description, but that symbol is a domain. It looks like you would think it's called a cell, but it's not. It's a domain. So that domain plugs into the domain input of the Subdivide Surface / isotrim.
Where did you get the Subdivide Surface?
Oh, yeah, I should probably. Again, that's the really confusing one, and it's actually under Surface, Utility, and I'll write it in right here, isotrim. Whoop, isotrom. Isotrim. Okay, so that's the tough one to find. And this one was under Maths Domain. All right, so we're missing one thing. We're missing an input of a surface, which really means we just complete the triangle and we pull the surface also into the subdivide surface. So let me hide this real quick because that's irrelevant right now. All that seemed to do is take my plane and it cut it up into 5 subdivisions. You guys all right over there? All right. true. Yeah.
What are the limits, the maximum and minimum of the two sliders that went into the divide?
Here? Those?
Yeah.
So those are as if, think of it like this. Rather, I know that we're setting it up in two-dimensional space right now, but we're going to switch it in just a second. But actually, I'll just show you. Okay, so the difference here is that while, if you're setting up a grid, grids in the X and Y axis can only function in two-dimensional space because they are the X axis and the Y axis, right? That's just how the Cartesian coordinate system works. But if I go into, and I'll just draw kind of a saddle pattern sort of thing here. I'll draw it loopy. So I've got, I'll do a few of these and I'll change the size a little bit. 2, 3, and I'll scale this one down a little. Scale this one up a little. And then I'll loft those. So let's take a look at it in perspective. So we have two surfaces that I modeled. I modeled a flat one and I modeled a three-dimensional warped surface. Okay, so the significance of U and V is that when I change this surface to the warped surface, U and V will adapt to the new three-dimensional developable plane. Okay, so I right-click on surface and I go to set one surface and I click this one instead, and now my subdivisions are happening along that surface. So it's kind of hard to see. Let me hide this real quick. There you go. Okay, so as I said, U and V, where they intersect, they will always intersect perpendicular to one another. That's the behavior. Okay, so while it's very, very wide here at this very extreme angle, and it's kind of more tight here in the center, that's what I was talking about. It's irregular in its spacing, but it has similar behavior to its relationship between, U and V and X and Y.
And so, as far as the parameters for U and V, you didn't set any parameters for that? For minimum and maximum?
I created a slider, so I can change how many are going across this surface here.
Oh, okay. That's
Yeah. Make sense?
Yep.
All right. Okay. So the other thing that I wanted to show you is what I was talking about doing the same command twice, right? Isotrim and then isotrim, or subdivide surface and then subdivide surface. Well, that really happens, if I wanted to have a minimum and maximum relationship along the edge of that surface, and it's very significant in one of the explorations we're probably going to do next week, but let me pull this down into position here, and whoops, I turned them off. Oh, there we go. So I'll pull that kind of up so you can see, and we have this subdivide surface. Okay, right. So let me pull all of my input values back into the same row, right? And so the significance here is that rather than pulling my source from the original surface, I'm going to pull my source surface or source domain from the developable domain, right? My subdivide surface that I can change. So I'll plug this surface into my eye, and it doesn't seem to want to behave. Untrimmed surface. Oh, right. So this also needs to be reparametrized. There we go. So I'll put that back in place. All right, so here's the relationship. The original surface, we have a reparametrized proportional relationship to the original geometry, and then now we actually subdivided that. So when we go back to our input, and I'll zoom in on this so you can see what's happening, I can change the minimum and maximum spacing of where this is happening across that whole form. Right? Pretty significant. I can wrap it around in both directions. And at the same time, I can also change the count for the spacing. Okay, pretty powerful stuff, huh? So I just made a near infinite number of combinations of subdivisions of a very warped surface that would take you hours to do each iteration if you were to try and model it in Rhino. Right? Not that it can't be done, it can. So I'll separate the videos here because that's kind of a complete thought, but I want to just stop and say, does anyone have any questions about that? None. All right. Cool. You guys are sharp. All right, I'll stop this here.